Well, good afternoon, everyone. And I've got kind of the lucky spot here. We're after lunch, but you haven't been sitting there long enough to get comfortable and fall asleep. So I'll try not to put you to sleep. I was asked to talk a little bit today about some of the experiences we've had in doing some of our mmWave trials. So I'll kind of walk you through a little bit of some of the testing and trial work we've done, some of what we've seen, and kind of the lessons that come out of that. So we've been working on the component technologies of what ends up being NR for a number of years. And as most of you, or all of you probably know, a lot of those component technologies are actually becoming part of LTE as well, right? And we're starting to put some of those out as part of our LTE networks. One of the things, though, that's really unique about 5G is the use of the mmWave band. And the question about how well is that going to work for fixed applications versus mobile applications. So we began back in 2015 doing some initial testing around Austin just to see how well mmWave would operate, what kind of range we could get, what kind of throughput we could get. Tested several different bands, and we did a lot of lab work around some of these capabilities. We've also been doing some work in channel sounding, which I'm not really going to go into too much, because the channel models for mmWave needed to be developed. Many of the channel models we have in 3GPP were primarily impacted by measurements in Europe and Asia. So we also want to see how it's different in much of the North American market. So we're doing a lot of work in channel measurements as well. So back in 2016, we did our first mmWave trial with somebody, and we partnered with an industrial or an enterprise partner to do a fixed wireless application. So we put the antenna up on top of our building, and we communicated with a company that was in the enterprise building about 250 meters away. Now, as it turns out, they happen to have windows with some amount of coating on it. I don't think it was fully low E kind of glass, but they had a coating. And as you might expect at that range with a coating, we couldn't get any connection from inside. So we ended up taking the pane of glass out and replacing it with a standard uncoated glass, and then everything worked fine. So we began doing that trial, and we were running enterprise applications that you might expect, all the video conferencing, internet access, and so forth. Let them use that for a while, see whether there were any impacts from weather, see what kind of stability we had, what kind of throughput we had, what their experiences might look like. All of that was done, by the way, at 28 gigahertz, and what I'm going to talk about today has all been done at 28 gigahertz because that's where equipment exists for us right now. So it was towards the end of 2016 when we did that, and after getting some good data out of our enterprise trial, we then expanded that to small business and residential use, again, near our facility. So okay, that doesn't seem to point, okay. So you see that what we had done is run fiber to a couple of telephone poles that we have along the streets going up north out of our facility. We put the transmit points on those poles, and we served a number of small businesses, a church, and an apartment. This again was at 28 gigahertz using 400 megahertz of spectrum. We then allowed them to try that out, see what their experiences looked like. Again, looking at what does it take to get coverage. And again, because this equipment was fairly new, it was not outdoor hardened. So all this had to be indoor, and ran into some of the issues you might expect indoor. One of those places was a car wash. And the guy who was working with us at the car wash was very excited to be the world's first 5G car wash. So So he was providing internet access to his customers as they wait. But there was only one place in this facility where we could actually put the equipment. And it was right where people like to go out of the door, and then they'd line up along the window out in front. So we had a number of issues with that link failing. But it did work well when we kind of asked people not to stand in front of it, and they gathered over in another location. We also had a church shown on the picture here, this white building. The two yellow areas here, these are the poles where the transmit and receive points were deployed. And what we ended up doing with the church as sort of a precursor to some of the other work we did that I'll talk about in a moment, was that we used our mmWave link in two places with the church where you may not be able to see those purple dots very well. But we had the fixed devices in the church behind glass, and then we served Wi-Fi access points within the church. In one place, it was an area where there were a lot of offices. In the other spot, it was actually feeding a gathering hall and in the sanctuary. I was surprised that they wanted it in the sanctuary. It's like, you really want people surfing the web in your sanctuary while you're doing your sermons? But he said, well, no, how else would they download their Bibles and see all the different things that we do during our service? So they're a little more progressive, I guess, than my church. But they wanted high-speed access in their worship spaces. So we did that, and that worked out very well. We were able to serve better than a gigabit per second to that church, and then spread it through access points throughout the church. We also served an apartment building, and you can see it on the picture here, again, that purple spot. And it's difficult to see in this picture, I know, but if you look a little closer, you can see there's a lot of foliage in between where the base antenna is and the apartment. Now, this was on the second floor, but in that case, it was up really in the midst of the foliage. We found that, in fact, this was at about 110 meters, I believe. We were able to get a signal through that foliage. So we had kind of anticipated that was going to be a difficulty. We were able to get it, but what we also found was that if you kind of face straight out of that apartment, the base station was off kind of in this direction as you looked at it. But what we found is that we got a much better signal if we pointed the antenna kind of straight out this way. And we found that we were able to get a bounce off of some object in the parking lot out there that was giving us much better performance than trying to go through the foliage. So interesting ways that you can use in order to get coverage of places that you might not otherwise think you could. So we had ranges anywhere from 90 to 250 meters. We were looking at throughput somewhere between 400 and 1,000 megabits per second in general. This is a picture here of the poles that we used and the transmit receive points there. The infrastructure was with Ericsson, and the end user equipment was from Intel. So after we did that for a bit in 2017, we also set up 3 pilot locations. You may have read some about in Waco, in Kalamazoo, Michigan, and South Bend, Indiana. We've been running those pilots, getting a better feel for coverage, letting additional customers of different kinds use the service, give us some feedback on that, looking at the different weather conditions, foliage conditions, and so forth. We've moved on now in Austin. We're no longer providing the fixed wireless services. We're now moving into mobility testing. So we've kind of taken down the fixed wireless deployments, and those poles are now being used to provide service along the road you see there, so that we can verify, in particular, beam management in mobile applications. And I'll talk a bit more about that. So with all of this, we're looking at things like beamforming, single user, multi-user MIMO, the propagation, penetration, what kind of throughput we can achieve, what kind of ranges, excuse me. And also to take a look at the latency. Now, this is not NR, this is pre-standards equipment based on 5GTF. and JTS. So it's, but we are seeing latency under 10 milliseconds. So this is another view of that area in Austin. And here on the top of the picture now, we'll reorient you a little bit, is the church. And down below is the road, and you can see sort of by different colors the different TRP coverage on this road. And we put up 4 TRPs to cover a fairly reasonable stretch of road. I think we have almost half a mile coverage here. We tested both inter-BBU and intra-BBU handoff, and we've done that up to speeds of about 30 miles an hour or so. Now, what we have found is in doing that, it's a very busy section of road. You kind of take your life in your hands. So we are building out a new lab and an area where we'll have a longer stretch of road. We can have more flexibility on where we place the base station antenna equipment, and be able to go up to higher speeds. But we have been successful in doing this deployment, and we've seen that we started off with about 1.7 gigabits per second, and even during the phase where we were doing bouncing kind of back and forth between the different TRPs, we still stayed above a gigabit per second. So we showed that the handoff will work. I thought I'd give you one example of some of what we're doing in the pilots, and this is for those of you who are familiar with the show. My wife would kill me. Fixer Upper, there we go. Chip and Joanna Gaines, they have an area called Magnolia Silos. And it's a bit of a shopping area. You see over there on the far right, there's kind of a warehouse and shop building. Then they have an area where people can congregate, food trucks, and so forth. The base antenna is on this pole that you see over here, and one of the small windows on that white warehouse is where the fixed device is, sitting behind that window. So it's about 178 meters. What we did is feed that with the 5G, and then we deployed 12 Wi-Fi access points within the store and around the grounds. You can see some of the yellow squares there. The pictures down below on the left are when they get busy. So one of the questions was, how well can we manage all this traffic? Can we get a lot of traffic across it, make sure things are stable and so forth? Now, obviously, the people are not directly accessing the 5G system. They're doing it through the Wi-Fi system that we have in place. But we used an AT&T FlexWare Wi-Fi, virtualized Wi-Fi system here, end-to-end with vRAN and vCore, and mmWave throughput, again, using 400 megahertz channels. With that, we were getting anywhere from 1.2 to 1.4 gigabits per second down, and about 200 megabits per second up. Obviously, the TDD ratio was set up primarily for downlink. The Wi-Fi clients were pretty much limited to about 200 megabits per second. But what we found during this event, they call Spring at the Silos, I guesstimated based on pictures, there were over 1,000 people on the, in that small area we looked at. It turns out there were 70,000 people over a 3-day period. So that shows even more popular than I thought it was. We opened up the Wi-Fi access. We had up to about 265 simultaneous users on the system at any given time. And they consumed about 120 gigabytes per day. Our average throughput was in the, kind of 50 meg down, 12 meg up kind of range, and that being limited by Wi-Fi. We were seeing ping times of about 22 milliseconds going all through the Wi-Fi system, through the 5G, through the core, and out to the internet. And time to first byte in sort of the 38 to 48 milliseconds. Now, given the number of people that were there, I thought that was pretty reasonable performance. The only interesting thing that kind of surprised us over time as we did this is you can see where that window is. It's about 14 feet up. And when they have trucks come in and deliver, it does not block that window. But every time they had a truck come in and park under that window, we saw real performance degradation. And so we think we're getting bounces off that truck and getting some destructive interference. So you've got to be careful about where you place these antennas. One of the other things that was kind of interesting is we plotted downlink radio utilization, which is the dark bars, and uplink radio link utilization over time. And this is from December of 2017 on through, near the end of March. And what's kind of interesting about that is you see how varied that is. You know, sometimes there was very heavy utilization of the downlink, other times not nearly so heavy. And you see when you go out there and look at what people are doing, there's an awful lot of this going on, right? Lots of selfies, lots of video, lots of uplink. So one of the other things that we're going to be doing is testing some different TDD ratios. And we're going to test dynamic TDD and see if that improves the performance for the end user. But that's going to be, I believe, important in the 5G systems as we move forward, particularly in the millimeter wave, the ability to do dynamic TDD. So just to kind of wrap up, I guess, a few of the lessons learned, as everybody certainly was well aware, clutter, foliage are key issues when you look at millimeter wave. We did find that we could get coverage that was better than we anticipated in some cases. We have had some of the installations, for instance, where we actually found we could put the antenna on the inside of the house up against the wall and get signal that comes through the wall. Now, of course, you have to be reasonably close. And in that kind of case, some of the foliage and glass coatings were worse than the loss that you get through the wall. But there were more than one way to skin that cat as far as getting coverage. We can penetrate ordinary glass, but low E glass, you aren't going to go through. You get about a 40 dB loss in low E glass. But of course, anytime you penetrate an object with millimeter wave, you're going to get a substantial loss. You want to leverage reflections when you start looking in particular at millimeter wave systems. And this is going to be very true, of course, of mobile systems. As you think about it, it's not just a matter of line of sight to the antenna. It's going to depend on the environment and the construction of that environment and so forth, but you can leverage the reflections off of other objects. Consistent coverage with millimeter wave, I think we also all realized is going to be a challenge. And one of the things that is part of the NR standard and will be standardized as part of Release 16 is called IAB, or Integrated Access and Backhaul. And we think that's going to be a really key, important capability in order to make a rollout that is both consistent and reasonably expensive. Okay, I'm being given the hook. So weather at these ranges really has not been a problem. Fixed wireless, you want to mount that antenna outside. Again, probably something we all knew to begin with. But in millimeter wave, mobility is viable. We can do that. RAN latencies showed up where we expected them. Dynamic TDD we think is going to be useful. And we did also in our home, in our apartment, we demonstrated full wireless home kind of capability. So we were doing video conferencing, internet, streaming DirecTV Now, and doing a 360-degree 4K immersive video all simultaneously. And it was working just fine. So it becomes something that we can consider as a reasonable approach for a service to the home. And I guess with that, I'll stop there and see if there's time for any questions.
So we do have a question here, and we'll take that one question because I know I had to give you back a few minutes. So we have a microphone right here, please. Thank you.
Yeah, for the MDU coverage case, did you say after foliage coverage was okay? Was that a direct penetrating through or from multipath?
Well, so you can't say any of that in general. In the case that we were looking at, Yeah, the direct path was through foliage, but then we actually got better performance off of a reflected path than we did through the direct path.
Okay, thank you.
Okay, thank you very much. We
All right,
appreciate it
thank
very
you.
much, Dave. Thanks.